So this next question is not based on a worksheet, but it's just to clarify the three different types of acceleration. Okay, so essentially we've got three different types of acceleration, and two of them are a result of changes in speed. Okay, for example, let's imagine that an object is orbiting at 0.5 radians per second. Okay, that means it's going around the circle. Okay, and it is going at a speed, or it's covering 0.5 radians every second. So maybe in the first second, it covers this kind of area of 0.5 radians. Then in the second, it covers this area. So it's traveling at a speed of 0.5 radians per second. Okay, then let's imagine once it gets to this point here, after 2 seconds, it increases its speed. And now it's traveling, and it's covering 1 radian per second. Okay, so all of a sudden, it's going a little bit farther each second than it was previously. Okay, so in this scenario, what has changed about this object is it has increased, or it has an angular because its movement around the outside of the circle is all of a sudden going faster. So because W has increased, we have an angular acceleration. And this could happen if W decreased as well. Okay, if it was going 1 radian per second and then all of a sudden it slowed down to 0.5 radians per second, we would also have an angular acceleration. Now, because W is measured in radians per second, angular acceleration is going to be measured in meters or radians per second squared. Okay, so it is we call this a circular quality or a circular quantity because it's measured in radians, not in meters. Okay, then we can also have a tangential velocity, okay, which is the velocity of the object if it were to be released in a linear direction. Okay, this can also change or increase. So let's imagine I am spinning my keys, okay, and I release them, right? Initially, they might be going, let's say, 5 meters per second. But then over time, as they're released, they're probably going to slow down and they might not be moving as fast. So let's say at the end of this distance, now they're only going 2.5 meters per second. Okay, this indicates that there has been a tangential acceleration, which is AT. Okay, and that's because our tangential velocity, which is V, has increased or decreased, which is giving us that tangential acceleration. Now, this one's actually measured in meters per second squared because the tangential speed is measured in meters per second, and that's what's changing. So our acceleration is going to be meters per second squared, and this is a linear quality, right? This change in speed is in one direction. It's not at an angle. It's not moving around a circle. It's just that linear speed that the object would be released at if it was moving in a straight line is changing. Okay, so this is a linear quality, not a circular quality. Okay, then we have our final type of acceleration, which doesn't involve a change in speed. Okay, so this one happens because even if the tangential velocity is the same, the direction of the tangential velocity, okay, at different points of the circle is going to be different. For example, if I have an object here, right, its tangential velocity has a direction of this way. Okay, but if I get that same object at this point in its orbital path, then its tangential velocity is this way. So because the direction of the tangential velocity is changing, we have a third type of acceleration that is associated with that called centripetal acceleration. And centripetal acceleration is the most important one because it tells you that an object is moving in a circle. Okay? Even if there's no angular acceleration, if the tangential speed is not increasing, and even if there's no angular acceleration because the angular speed is not increasing, right? We can have objects that are moving in a circle that don't have angular acceleration and don't have tangential acceleration because they're moving at a constant speed. We can't have an object moving in a circle that doesn't have centripetal acceleration because this centripetal acceleration is caused by the change in direction of the velocity. If the velocity is not changing direction, then this object's not moving in a circle. It's moving in a straight line. So centripetal acceleration is the only one that you have to have in order for an object to be moving in a circle. Okay, so centripetal acceleration is the result from the change in direction of tangential velocity, which is v. Okay, it's also measured in meters per second squared because tangential velocity is in meters per second squared. In terms of understanding this, essentially, this acceleration is a vector. Okay, so we've got our initial velocity, which is here. Okay, and then we're actually going to add the negative value of that velocity, okay, to give us the change in velocity, and then the resultant vector between those things should always be a line pointing towards the center of the circle. Right, so essentially we've got our two component vectors and they create a resultant vector which points towards the center of the circle, which is why we call this our center-seeking acceleration, because the direction of our two component velocities should always form a resultant velocity that points towards the center of the circle. Okay, hopefully that clarifies the three different types of acceleration a little bit. Let me know if you have any more questions.